last lesson helped us if it already had log in it, how we use our log rules to condense it down when it's from expanded form. So minus goes with divide and add would go with multiply. I didn't do one of those, but maybe we're going a little bit. But anyway, those are if log's already in the problem in expanded form. Now I'm going to show you the other type of problem you're going to have in your homework. So this is directly from your 4 or 5 homework. If you have an unknown exponent, and that's really, to me, the heart of why we learned how to do logarithms is so we can solve all these applications that we're going to see in the next section where we don't know what the exponent is. We have solved all types of equations with x in it. X has been squared, x has been to all kinds of powers, x has been in a denominator, x has been all around, but it's never been the unknown exponent. So this is a new concept for us. So the way we're going to bring this exponent down on the level where we can work it out is that logarithm rule. Well, right now it does not have the word log in it at all, so you can't use the logarithm rules, right, since it doesn't have a log on it. So we take the log, which can be either ln or log, take the logarithm of each side, and now it is a log problem. Because it has the logarithm on that, the exponent now can come down as a multiplier. We can say that's x times ln4 equals ln2. And you need to know that ln4 is just a value you can get off your calculator at any time. If you want to, right here, you can say, what is ln4? But it's not a pretty number. You know, it's a long, irrational decimal. So if you write it out, you're going to lose some of its accuracy because you have to round a little bit. So you want to try not to do that until you have to. So what I would recommend, instead of making this a number, in your mind, though, know that is a number. Just like x is times some constant, you would divide that out to solve. So dividing that on each side is perfectly legal in algebra. That makes x equal, then do that calculation. You want to have any round off there. ln of 22, close your parentheses, divide by ln4, and see what you get. I'll do that too, so you can check your work. Okay, so 2.23 we'll say to the nearest hundred. And it's really a squiggle line, remember, because it's a round off. You get that? Okay. So do the same thing again on number 2. Same trick, another problem. Again, by taking the logarithm of each side, because it did not say log in any way, we introduced the logarithm rules to it by taking the log of each side. That made this unknown exponent come down as a multiplier where I know how to work with it with my algebra rules. So x is multiplied onto that. Doing the opposite division will cancel that. And then I'll have x equals, and I can do that right directly on my calculator. Always check your answers, especially on your exam. You know, it's irrational and it will tell you what place to round to. But we can check this answer. Is 3 to that power equal to 10? That is what you should be solving as the original question asked. 3 to what power is 10? So you can check that easily, right? And we should, especially when we're testing. All right, 3 is really the same question, only we have a fraction to deal with. So just lots of practice with this new rule. ln at each side. And the big new rule is now the exponent is a multiplier. No matter that it's a fraction, it's the same sort of thing. You know, it's still a number. ln of 1/5 has a value. So type that into your calculator. You should get negative 1.54 approximately. You can check that out. Is 1/5 raised to negative 1.54 equal to 12. So now a good question you may have is that okay that we have a negative? You know, I talked to you a little bit earlier about not having a negative answer. You can't take the log of a negative number. And that is absolutely true. You cannot directly type in log of negative something and get an answer to say error. But in this case, we were solving for the exponent. The exponent can definitely be negative. We've had negative exponents before, and the way to know for sure is ask your calculator. It will friendly say back to you that this is okay and give you an answer. 1/5 raised to the negative 1.54 should verify that it is 12. So you should be able to be okay if you'll just remember to take your time and double check your answers. Okay, any questions on that? Okay, number 4, we're going to step it up a little bit, but it's really nothing new. It's the same concept. It's just a little more of a mess because the exponent has 2 parts to it. So when I take the ln of each side, still the same deal with that, it makes the exponent, which is now a quantity, come down as a multiplier. So watch, since it's a quantity, x plus 6, I will need to keep that in a parenthesis to note that. So this exponent comes down to x minus 3 times ln 4. And then we have some distributing to do. Just like any other number. Now listen, your calculator knows this as a number. It's calculating e to what power is 6. So that is just some constant value. So think of it as a multiplier. Think of it as just a 6 if you want. Because it's not a mystical character or something. It's just a value, just a constant number, and we distribute constants. So it'll be x times ln of 6 plus 2 times ln of 6. Distribute here, 2x, ln of 4, and minus 3, ln of 4. So just distributing that constant that we found, constant multiplier. And then we gather our x's. You know, if you're solving for x, you want to get all your x terms on one side and everything that doesn't have an x to the other side. Your constant thrown to the right side. So I'm going to bring this x term across. So I've got x ln of 6. And then when I bring this over, it'll be minus 2x ln of 4. So gathering the x terms. So this is a constant, 2 ln of 6. There is no variable in that. That is a constant. It goes to the right side. So it becomes negative 2 ln of 6. And bringing that down, minus 3 ln of 4. So you see, it's just kind of messy. You can kind of get lost in the terms if you're not careful. So, but I keep telling you to emphasize this 2 ln of 6. If you didn't like looking at that new notation with the ln in it, you could say, calculator, tell me 2 times ln 6 equals, and you could have a number there. But, you know, you'd have to round it off a little bit, so it'd be awkward because you might have a round off error. But it is just a number. So the number here changes sign when we throw it across. All right, because there are 2 x terms, I'm going to factor out the x. That leaves ln of 6 minus 2 ln 4. Just took the x right out of that and left minus 2 ln 4. And again, this is just a number on your calculator. We could type it in at any time. This just wearies us, and you might be thinking, I'm weary now. So if you prefer to look at it as regular numbers, you can, but that is just a multiplier on x. So we divide that out. Whatever it may be, divides out and just leaves x solved for. So divide the other side, and then this is a practice in our calculator skills, getting our answer to come out for us. So I want everybody to type this in. Make sure you do the numerator, get your total answer to the numerator, maybe use